What's up, you math maniacs? This is Mr. Bergman here, section 1.1, day number 2. Apply properties of real numbers. Today we're going to talk all about units, and units are super important because units like dollars and seconds, minutes, feet, miles per hour, ounces, all those things help us tell the story through unit analysis. And if you're a sophomore, then you're going to use this quite a bit. I mean, we use it a lot in math, but if you're a sophomore taking chemistry this year, then you're going to do quite a bit of it. It's called stoichiometry in the science field. I mimicked the way they do it here so that you can, when you learn it here, then that'll help you in chemistry, I hope, a little bit. Here's some big ideas. First of all, if you want to rate, then you have to divide the units, and it's often going to be a unit per time. So if you have miles and you have hours, then you can divide the miles by the hours to get the miles per hour, and that's like a rate. Feet per second, same thing, or even like dollars per day. So if you want to know what is your earning rate down here, then you take the number of dollars you earn and you divide it by the number of hours, and that'll give you how quickly you're earning money in dollars per hour. Notice the word per is a super important word in this. The second big idea is that if you want to convert units, we're going to multiply by a fraction that equals 1, and that'll help us cancel out the units. I'll explain more about that in a second. So check this out. But in order to get us started, let's review. If you want to simplify the fraction 20 over 50, what you really got to do is figure out what number goes into both 20 and 50, and that's going to be 10. And at 2 times 10, 5 times 10, because it's in factored form, you can cross these out, and then you just get 2/5, and that's your simplified answer. Let's take a look at that. You work 8 hours and earn $60. What's your earning rate? Remember, to find the rate, we have to divide something by time. In this case, it's going to be the dollars divided by the number of hours. So it looks like this, $60 per 8 hours. And division and fractions are very intimately related, so we're just going to use the $60 and then fraction bar 8 hours, and that's actually going to simplify to $7.50 per hour. You can grab a calculator, something like this. 60 divided by 8 is 7.5. Okay, so that's kind of the first big idea, divide the units. The second one is going to be converting. Let's say you want to convert 18 feet to inches. Now, I know all of you have lots of different ways of doing it. I'm going to try and build up a way that's going to handle something more complicated. So I'm going to use a very specific method to do this, and I hope you'll learn that very specific method because it'll scale up to way more complex ideas. Basically, you want to start. The first thing you got to do is take your given and turn it into a fraction. So it looks like this: 18 feet over 1. And then you got to think to yourself, well, what are the starting units? I'm starting with feet. And is it in the top or the bottom of that fraction? Sometimes it's going to be in the bottom or a blend of top and bottom, but right now it's just in the top. Then you have to think to yourself, what do I want to turn them into? What are my ending units? And in this case, it's going to be in inches. So I need a fraction that compares feet and inches, and it's going to help me cancel that feet. Now notice here, stuff cancels when you see in both the top and the bottom, the numerator and the denominator. So my canceling fraction in this case is going to be 12 inches over 1 foot. Now, why isn't it not the other way around? Why didn't I put feet on the top and inches on the bottom? Well, the reason is because when I go to do my work, I can start off with my starting fraction, and when I multiply it by my canceling fraction, the feet cancel out. Feet on the top here, feet on the bottom here, and they cancel just like this here. Now, if I had flipped it, if I had put the 1 foot over 12 inches, if it was feet on the top and feet on the top, then that wouldn't help me cancel out. So it wouldn't really work in this situation. But because I chose my canceling fraction to be this specific way and not the flipped way around, then the feet will cancel top and bottom, and I'm left with 12 inches over 1 and 1. And if I multiply across, then I get 18 times 12 is 216 inches over just 1, which simplifies down to 216 inches. And that kind of makes sense. Like 18 feet, that's a whole lot of inches. Okay, so let's do this again. Let's keep it just 1 unit, like 20 ounces. Let's change that 1 unit to pounds. Again, we're doing a complicated method because it's going to scale up. So let's go. The starting fraction, take your given and turn it into a fraction, 20 ounces over 1. The units, you can think to yourself, when you're actually doing these problems, like this is the actual work, and you don't actually have to write all this down when you're doing your practice problems. But I wanted to lay it out. Please do fill out this table here in the notes so that we know what to think about. So the first thing you think about is what is the starting fraction, and then what are the starting units, and those units are in the top. The ending units are going to be in pounds. So what I need is a canceling fraction that will convert ounces and pounds. If you don't have it memorized, there are 16 ounces in 1 pound. And look at this. The 1 in this case is in the top and the 16 is in the bottom. It's opposite of here. Now, why is that? It's because I want to cancel out these ounces. They were in the top, so I need to put ounces now in the bottom to cancel them out. And how many ounces and how many pounds? Are 16 ounces in 1 pound. So the work looks like this. You write out your starting fraction, and then you write out your canceling fraction, and then you notice that these ounces are going to cancel, and you have 20. And then when you multiply across, you're left with 20 pounds over 16, which you can grab a calculator if you want and turn that into 1.25 pounds, 20 divided by 16. All right, so your audio check for today is that in my youth, my sport was soccer, and my senior year, I was the captain of the soccer team. It was not because I was great, it's because everyone else was worse. That's your audio check. Okay, up until now, you probably had different ways of doing these kinds of problems, like converting 18 feet to inches. You might have just thought to multiply 18 times 12, but it's going to get a bit more complicated. So, for example, 3 years to hours, you might be like, how am I supposed to do that? Well, again, let's think about the starting fraction. Starting fraction would be, in this case, 3 years over 1. And then the starting units would be years, which are on the top. The ending units are going to be in hours. So the canceling fraction has got to be, we're going to put years not on the top, but on the bottom so that it cancels. And then we'll put days up top. Now, this is not the only canceling fraction. We're going to have quite a few. So the work looks like this. You start with your starting fraction, 3 years over 1 times the canceling fraction. Notice years are in the bottom so that they cancel. And then we've got 365 days. Now we can do another canceling fraction to get rid of the days. Days are in the top, so we put days in the bottom. And in 1 day, there are 24 hours. Okay, so our ending units are hours, and now we've canceled out all years, we've canceled out all days, and we're left with only hours, and now we've got numbers as well. You're going to multiply them all across the top, grab a calculator, and it's 26,280 hours over 1 times 1 times 1, which is just going to be, well, you tell me, it's a red dot. Next, when you divide those two, you get 26,280 hours, and that's your answer. This way of, so one really powerful thing about this is that it's stackable. You don't just have one canceling fraction, you can have multiple canceling fractions, and then it'll take you from one unit to the next, to the next, to the next. For example, here, we've got 45 miles per hour, and that's going to be our starting fraction, 45 miles over 1 hour. So this is our first example of something both in the top and the bottom. And that's okay. The starting units are going to be, we'll have miles in the top and hours in the bottom. Ending units, we want to have feet in the top and seconds in the bottom. We want it to be feet per second. So what do? A first canceling fraction, let's just get rid of the miles. That's actually, you can't get rid of both the miles and the hours at the same time. You got to do one at a time. The order doesn't really matter. Let's get rid of miles. So let's put miles in the bottom so it cancels out miles in the top. And how many feet are in 1 mile? Well, we've got 5,280. And I'm choosing feet because I know my ending units are going to have feet in them. So if I can get rid of miles and replace them with feet, that's a win. So we're going to start with 45 miles over 1 hour, and a first canceling fraction is going to be, like I said, miles in the bottom to cancel out the miles in the top, and then 5,280 feet in the top. So now, if I were going to stop here, I would have the feet, I'd have these numbers, and then feet in the top and hours in the bottom, but I want to cancel that out also. The way you cancel out hours is with minutes and hours. Notice, to cancel out these hours in the bottom, I'm going to put this unit, hour, in the top. It's not 60 over 1, it's 1 over 60, 1 hour over 60 minutes. And in this way, I can cancel out the hours. I put this hours in the top so that I can cancel out this hours in the bottom. and I'd be left with a number of feet, and then 60 minutes. But I want to remember my ending units have got to be in seconds. So I got to get rid of these minutes, and the way I do it is with another canceling fraction. I've got 1, 2, 3 canceling fractions. One to get rid of the miles, another one to get rid of the hours, another one to get rid of the minutes, so they're left with only seconds. So, and the reason I put 60 on the bottom instead of the top is so that I wanted to put this minutes up here to cancel out this minutes down here. Top and bottom cancel, and so now I'm left with seconds. And I got all these numbers. So what I'm going to do is I'm going to multiply all the way across. 45 times 5280 over 60 times 60. And I've got feet and seconds. And this is something you can just grab a calculator and divide the two and get a decimal. In this case, just 66 feet per second. 45 miles an hour is 66 feet every second. It's kind of fast when you think about it that way. Now, that's for converting, but you can actually also use this to solve some word problems. For example, you're traveling for 2.5 hours at 50 miles per hour. How far did you go? So the starting fraction, what are you starting with really? You're starting with 2.5 hours over 1. The hours are in the top. And what I want at the end of the day is a distance. Like I want to turn this into a distance. But, just spending time on the couch, 2.5 hours on the couch is not going to get your butt any further along in miles. There's hours and miles are not the same thing. So, but they are if you assume that there's going to be 50 miles an hour. So what you can do is you can use that as your canceling fraction. And I want to put hours in the top here, so I'm going to put hours in the bottom in my canceling fraction, and miles in the top. So here's how it all plays out. You got 2.5 hours over 1. That's your starting fraction. Then you multiply it by your canceling fraction. This is hours here, hours here. Hours are going to cancel out. And I'm left with 2.5, 50, and then miles is the only units. When I multiply across, I get 125 miles over 1, which is just 125 miles. So like I said, 2.5 hours is not the same thing as 125 miles, but it is if you assume you're going 50 miles an hour. So that's how we were able to convert from one thing to another. Anyway, thanks for listening, y'all. Bring your questions to class, and I'll see you there.